Hello.
Good morning.
Morning. All right, so I don't know if you had anything you wanted to update us on or share.
The videos dropped of the Alice Summer School and the CDPR workshops.
All right.
This is like big day-long workshops that are online now. If there was so many, it was hard to, the Alice was focused on healthcare and biology. Data Sci ML has got the Ellis, and then
the Ellis, yeah, okay. Healthcare and biology.
Yeah, that was the Manchester one. There was definitely a couple embodied ones. Here, I'll find this CDPR.
Hello, everyone.
Hi, how are you?
Hi, very good.
So, Sarrah, would you like to give an update?
Yeah, sure. Okay, just a second. I'll go ahead and share my screen. Okay, so last week, as we had discussed, I had created a single contributor agent and single maintainer agent kind of model. And the next step was to figure out how to go from single agent to multi-agent. And for that, I had proposed some ideas, and what we decided was I'll try to use two different approaches that I'd shared from LangChain. Which were using a decentralized approach where the contributors decide for themselves who among them would be the best for that issue, and versus using an authoritarian approach where some authority figure, which in my case would be a maintainer agent, selects one of the contributor agents for each issue. So basically Bradley's suggestion was that I kind of go ahead and implement both of these so that we could run both of them and see, and also offer that choice in the final this. And then so the initial plan was that up till now for my agents I had for the contributors, the main thing was that they should be available, which is they should be kind of the equivalent of being online at some time and not already being working on a task, and the fact that their experience level should match. So this is what would comprise the eligibility to be able to do a particular issue. So last week, any agent could do the issue, but the problem that would arise is there would be many contributors that would be eligible, but only one of them would be able to do the issue at any one time. Until it was merged, nobody else could work on any such issue because of the fact that it would create merge conflicts. So to address this, there are these two algorithms that I tried, and they also correspond to two popular models in open source. The first one is the benevolent dictator model, which was simulated using the authoritarian algorithm. So now, after I started implementing this, like in last week's meet only, Himanshu had written quite a big paragraph of questions in the chat, but I think by the time I answered them, he had left the meet due to some issues. So I had a meet with him later on as well in the week, and I again kind of wanted to get his thoughts on this whole idea. So one of the questions that he asked was, what are you basing this on? How is this different from just randomly selecting one of these contributors? Because your entire thing is selecting. So how is implementing these algorithms different from just randomly selecting one of them? And so like I was thinking on that, and I was thinking of how to make it as similar to our open source model project, because the examples that I was referring, the LangChain examples, they were for a debate. Like in a debate, either the central person decides who speaks next, or the people who are debating decide amongst themselves who speak next. So I was trying to kind of make this analogous to our open source project, and what I came up with is the idea of comments on a GitHub issue. Like so far we have GitHub issues that I have in sort of markdown files such as this. So far I have like GitHub issues in such kind of markdown files that I'm giving as input to my LLMs. So what I thought of was that at any single point of time, like at any time step in the simulation, all the contributors that are eligible would be that they are available online and free, and that their experience level matches the difficulty level required for the issue. They would all come up and contribute their thoughts on this issue. And this would be analogous to what even real people would do whenever a new GitHub issue is made, because before someone directly starts solving it, usually some approaches are discussed in the comment section. So I thought of simulating that, and once that is simulated, that gives us sort of a conversation history to go on. And then based on the conversation history, I implemented these two algorithms. The first one, the authoritarian algorithm, which kind of has the maintainer rate each contributor according to the comment they give. So I'll just go through this. So the first is the benevolent dictator model that we implemented using the authoritarian algorithm, which was in a LangChain tutorial notebook kind of thing. And basically in open source, this model is there is a single leader who steers the project and makes decisions and guides contributors. And this is like some information I found out from an open source site that I referred. I'll add it in the references later. So how I implemented this was, first I did an eligibility check to filter the contributors based on their availability and experience. Then simulate a discussion among these contributors, which would be somewhat like a GitHub style discussion. And then based on the discussion and based on what each contributor commented in that discussion, the maintainer would rate that contributor. And also, and once the maintainer rates each contributor according to the comments, the contributor with the highest rating from the maintainer would be selected, and the task would be allocated to that contributor. Then the contributor would create a pull request, and then the maintainer would merge it. So right now I'm not working with the exact code that I was last week. Like that also had contributors and maintainers, and they were using autocode rover to actually solve the issue. Currently, I'm just because I'm focusing on this algorithm, I've just created a similar type of class in which those functions are kind of empty functions. Like it just assumes that the issue comes out solved without actually solving it, and I'll plan to integrate it later on. So, so yeah, this is kind of the output of the authoritarian model. Where I start a simulation with 2 issues and 5 contributors, and at time step 0. So this is the description of the first issue that I referred previously. Also, it is basically to add the functionality in a calculator, kind of a feature request issue. Then among the available maintainers, one maintainer is randomly selected and is allotted this issue. Once the maintainer has been allotted the issue, the eligibility check happens. So currently, all 5 contributors are eligible, and these numbers are their experiences. So basically, because the issue experience is less, all of them are eligible. Then here is the GitHub style discussion. So the it starts with the system adding the issue description. So the contributors kind of need to know what they are talking about. And then here is the comments that each contributor gives on this issue. And they kind of say that how they will approach this. And of course, this is not using autocode rover, or it is not like they don't have access to the code. So these are slightly more abstract, but the only point of these is to help the maintainer make a decision. And later on, like the actual solving will be done separately. So they all give some kind of an approach, and based on that, the maintainer rates them. And so now it's still running. So each of these is an LLM call. Like this would be the first LLM call where each contributor is asked by invoking the LLM to give their thoughts. Then this is also an LLM call where the maintainer agent's LLM is kind of asked to rate these contributors based on their response. And now, as you can see, that it has given quite a lot of contributors a very good rating. So then among these, since I have no other option now, among these, it chooses one randomly. So here it has chosen contributor 4. And then contributor 4 is allotted this issue. And then the solve task, like as I mentioned, I've not yet implemented it. It is just an empty function. So this is the authoritarian algorithm. And then similarly, I have the decentralized algorithm. Slightly, there are only few differences where so till here it is same. And then instead of rating, the contributors bid. So each contributor is given the entire discussion history, and based on the discussion history, they have that their name is also present in that discussion history. So they bid on their own suitability for the issue based on that discussion. And then the one who bids the highest with the same tie-breaking system, like 2 or more have the same, then randomly one is selected. So the one that bids the highest is selected. And yeah, so this is all for this week. Like I was working on these 2 algorithms, and going forward, I'll like either choose one of these or give an option to implement like give an option to the person who's running the simulation to choose which one of these they want, or I can choose it by hard coding in the code. So and I have to integrate it with the earlier code. So currently all this code is in a separate file, so separate folder of this decision making, and the earlier code was in this environment creation folder. So I kind of have to, they both have classes with the same names. I kind of have to integrate their working so that first the bidding part happens and then the actual solving part happens as well. So yeah, if there are any questions, then you have to answer.
All right, well, thank you, Sarrah. That was a very good update. Have you made a pull request yet? I just wanted to make sure.
No, because there are still like some figuring out.
Okay.
So once I do that, I'll make a pull request in the week. Like changing the prompts kind of does a lot with these. So initially I noticed that the comments that these agents are giving are not at all related to the issue. So right, they're like highly abstract. They're just saying I would like to collaborate and I would like to do this. So I'm trying to prompt engineer it in a way that it can be slightly more regarding the issue. And once I do that, I'll create it.
Sounds good. Thank you.
Thank you.
So. Oh, go ahead.
Yeah, go ahead.
Well, I was going to move on, but if you had something else to say.
Oh, okay. Yeah, so just the only thing I had was like, I just wondered like next week will be the sort of the midterm evaluation. So I just wanted to like go through my the timeline that I proposed and just kind of discuss how like what has been done so far. So this was my original timeline, and in it like the community bonding period was kind of to explore how I can solve this and some final metrics. Over that, I read the drive that was provided. I read some resources from that as well. Then the first week was to like, this was a very nice, very abstract kind of this where I was like, in the first 2 weeks I'll make the agents, and the next 2 weeks I'll make the interactions, and then the environment. It did happen in sort of the exactly the same way. Instead, I have 3 separate folders in the GitHub, where the first 2 weeks were kind of the preliminary design, where I proposed this design and did some testing on which LLM models would be suitable and how they can be integrated. And then the next 2 weeks, I worked on the environment creation, where which I presented last week as well. So I would say 2 to 2.5 weeks, where I worked on the environments and how the agents would actually solve it. And then since then, I worked on like going from single agent to multi-agent and how we can accommodate that. Yeah, so up till the midterm evaluation, kind of my main milestones were that I should have sort of a agent-based model running, and then post midterm I would try to add the real world or the metrics data and try visualizing the different metrics and such. So yeah, I think like it's not complete yet, but I think a base model, like what I suggested in this when I suggested this preliminary design, kind of a base model where there is agent environment communication, where they're communicating with AutoCode rover with the different tasks and issues that are stored in the GitHub environment locally, and making GitHub commits and pull requests. Then the agent communication, which is kind of done right now in the sense that they are rating each other or commenting on the pull request or merging the pull request created by someone else. And that is kind of there. A base framework is there, and hopefully by next week when I merge the code I have so far, it should be a proper framework. And then next, like sort of what I proposed in the proposal as well, and what I have here is these subtasks, which is to kind of add the first one was to add these personalized agent variables, where based on the issues they solve, their experience grows and different things happen. So that, and then if possible, hopefully also add some kind of an IRC simulation apart from the GitHub thing that we have. So so that is like my updated plan for the post midterm. So there are any thoughts or any kind of advice on how I've been doing so far and what I can either improve or I should change in my plan? I just wanted to discuss it.
That sounds good to me. We'll see where we can go. I think you've been doing very well so far. So we'll keep doing weekly updates, and then if we run into problems, we can kind of rescope there, or if we need to scale back towards the end, if you think you've bitten off more than you can chew, which is just kind of depending on how everything works out, we can decide there. But I think if you get at least some of what you proposed for the second half done, that should be a pretty good project. So
sure. Thank you.
Thank you.
Yeah, that's all from my side. Thanks a lot.
All right. Thanks. So I don't know if Hussain has an update. It looks like Pakhi and Jess are also here. So.
Yeah, I can go ahead. Yeah, I can go ahead.
Yeah.
Okay. Thanks, guys. Thank you so much for the updates, everybody. Happy Friday. I'm exhausted. I need to take like a summer vacation pretty soon, even just for 2 or 3 weeks. Yeah, so with the breast cancer computed tomography project, Chan-Zuckerberg, we've been making some good progress on. I can share. Let me get a notebook up. Grab my notebooks. I'll just share what I put on the GitHub. GitHub. Okay, so just to keep people up to speed, but if you guys have been following along, you should be familiar with this. Okay, so this is for the breast cancer computed tomography project, in which we are exploring some novel approaches to optimizing and making more efficient the methods of steering X-rays as they are used in breast cancer detection or breast cancer diagnosis. And I've shared pictures of what the hardware looked like. So I've shared pictures of what the machines, what the engines look like. And over the past couple of weeks, Dick and I have been performing simulations and ways of seeing how we can steer the X-rays as they reflect through these Janospheres. So using the mathematical calculations of the Bragg angle to simulate the reflection. This is an example of how the Bragg angles for X-ray reflection would be observed from an 11 by 11 array of circles. So ideally, basically, if each of these is a Janosphere and we shoot an X-ray, how would they deflect through an array that's 11 by 11? And this is one example, particularly considering each Janosphere, the X-ray would be deflected as it hits or zooms through the center of each Janosphere. But ultimately, we want to be able to plot the trajectories of the beams and see in what ways will the Janospheres need to be transformed accordingly. So the beams can be controlled in a way that's much more dynamic and effective from the engineer performing these, from the engineer designing the hardware, and from the scientists and software engineers creating the software for the simulations themselves. That's basically where we are. That's basically what we've been getting at. And yeah, I think a lot of cool stuff, a lot of great stuff what we're talking about. And we want to validate the X-ray paths against existing experimental data. We want to see if there could be an error analysis to see how the deviations could affect deviations or inaccuracies could affect certain things. So this would involve things like convolution, deconvolution, and like the MART algorithm, that's the multiplicative algebraic reconstruction technique algorithm, would be used to improve the image clarity and reduce the artifacts. Yeah. So yeah, basically, and moving from 2D to 3D, we want to, create 3D models of the Janospheres to simulate those things more effectively too. Blender is just not working out. I did just buy a new laptop that's much better for 3D simulation. Right now, I use a MacBook, and I bought a 4070. You're familiar with like laptop hardware? It's like it's an Alienware 4070 that's basically got a much more powerful graphics processing chip for simulations, development, to design. So oh, Jesse, you're asking like for contribution to this project between me and yeah, we can get more people on board. We definitely can. So we'll stay posted. We'll stay posted where the project goes and where the project is heading. Yeah, I'll outline some tasks, some assignments, a list of things that people can get on board with. Okay, so yeah.
That looks great. Looks like you've got a lot of code there. You're kind of moving along on putting in the pieces of what the code looks like, and that's nice. Yeah.
Oh, yeah. I think so basically what's really driving this too, as we talked about quite a bit, is that this does have the potential to be patented in some ways. Seeing if this can be used in if we can show that the research works, if we can show it's a solid, effective method of pitching towards various investors and people who can get on board from a business and patenting strategy, we'd basically be patenting the dynamic steerable X-rays used in breast cancer computed tomography research. So yeah.
Well, that's good. Thanks for the update.
Yeah, I'll post some tasks from some links for people to get involved with the Slack channel. I'll post in the Slack channel. People want some opportunities for people to get involved with us. So yeah.
Good. Thank you. I wonder if Pakhi, hello, how are you?
Hi.
Do you have any updates?
Yeah, so I was working on the NDP function from my last update, and I was able to sort of integrate the NLP function with the NDP function. Like I mentioned, I will be working on the training file, so I will try to get that done over the weekend. It's somewhat there, but I still need to run a few tests to make sure it runs properly. But yeah, I think I should be able to finish that by the next meeting.
Okay.
I was trying to fix a lot of things in the NDP and MLP function, so I didn't get a chance to make the PR. I will make one in these coming days.
Sounds good. Yeah, thank you.
Thank you.
All right. That's good. Thank you, Pakhi. Jess, how are you?
Hey, or not. I'm easy to hear or not right now.
Yeah,
but,
I can hear you.
Can you hear me?
Yeah.
I won't be able to bring up the task board, but I hope, I think we discussed some of those things with the GitHub project board. So outside of that, I don't have nothing to share here. I, again, encourage, it's good to see the updates so far, and looking forward to see where all those projects are going. Like I said in the Slack channel, if there's certain topics about open source development or careers in software development or technology or anything like that that you're particularly interested in, write in there or request something or whatnot, because we can try to tailor to that experience or that request. But otherwise, I'll have some other things to share in the future, but I'm kind of in commute now. So that's all for me for today.
That's good. Well, thank you. Thank you for the update. Okay. All right, so yeah, thanks for that. Let me share my screen and we'll talk about some other things. So we were talking earlier about some of the interesting stuff going on in the Slack. So I guess there was a video here that Morgan wanted me to look at, which was the video.
Oh, sorry. I was just saying one of those examples from CVPR was the continual learning.
Okay, where is that? This one or no?
It should be DevAI, the most recent. Sorry.
Oh, okay, that's fine.
let me put my glasses on.
Yeah, there we go. I was way back.
Yeah. Most recent. Yeah. Fifth workshop,
This
continual
one.
learning.
All right, yeah. So this is continual learning in computer vision. So this is, there's a lot of good stuff in DevAI, a lot of stuff having to do with workshops and, open source type things that, you might be interested in. So, of course, for those of you who don't know, we've done work. We started doing work, or sort of our origins of a lot of this stuff comes from when we've been working on developmental Bradenburg vehicles. So we actually have a repository where we have a number of those kind of simulations, the code for those simulations, and so that's that. And then we've kind of continued on in this vein, trying to develop different ways of looking at building intelligent agents, looking at some of the aspects of like nervous system development and embodied development and things like that. So we get a lot of things in this channel that have to do with like integrating large language models, robot learning, and even continual learning into what we're trying to do. So this is kind of a more sort of exploratory area for that. And then eventually we'll apply this to different topics in this area. And so that's why we have this channel. So did you want to say something, Morgan?
Well, I was just going to add open-ended learning.
Open-ended, yes.
That's like the Jeff Kloon. I mean, there's I hadn't seen something from Jeff in a long time.
Yeah, there he is.
It's just like a nice public talk.
Yeah.
Just as it's one of those interesting, somewhat unconventional thinkers in artificial intelligence.
Yeah. So this is some of his work on genetic algorithms. So open-endedness in AI GAs in the era of foundation models. So this is actually is generating algorithms, but yeah, so I don't know what AI generating algorithms are, but exactly. But that's the kind of thing that we're looking at in this channel. So yeah, and there are a whole number of things here. There's this synthesis course. So this is an introduction to program synthesis. We talked about program synthesis in one of our Saturday meetings, where we kind of went over some of the issues in program synthesis and then how it links to other things. So actually to large language models. So this is a course on this from fall of 2023. So it's a syllabus on how people are doing program synthesis using artificial intelligence. And the thing about this sort of a topic is that it's easy to sort of build programs because you kind of have the parts all there. They're very computationally tractable, but it shows kind of like when you build sentences and bodies of text, how you can build programs basically. So this is a nice thing to look over if you're interested in that area.
Certainly for some of the directions people have been suggesting about how to add symbolic logic in, and again in this kind of open-ended and more, I don't want to say not creative necessarily, but well, perhaps, but I mean, hopefully creative, but certainly compositional.
Yes. We've also done some other work on like continual learning and the things that we're doing with MetaBrains. So there are a lot of things I'd like to pick back up too, that in the new light. So this is good. I think it was Pakhi who asked, "Is this in the Slack or?" Oh, this is Jess. Yeah, this is in the Slack. This is Dev AI, and this is in the Orthogonal Lab Slack. So if this is not the Open Worm Slack. So this is a different Slack.
Oh yeah.
So that's this channel Dev AI, and I haven't gone over the repositories I just mentioned in detail, but I might do that in a subsequent week, just so that we know kind of where we are with that. So then, this was also brought to my attention, this tool this is from Microsoft Research Blog. This is GraphRag. This is a new tool for complex data discovery. And so this is something that Microsoft is invested in, where they have these graph-based approaches to retrieval augmentation generation that enables question answering over privately or previously unseen data sets. So they have a GitHub repository, so it's open source, I guess. It's in Microsoft, you never know. And they're doing, they have all their code here. They have this GraphRag accelerator solution. Let me talk a little bit about it. So I guess it interfaces with large language models. They have a prompt tuning guide here that allows people to sort of optimize what they're doing. This repository presents a methodology for using knowledge graph memory structures to enhance large language model outputs. So they're using knowledge graph memory structures, and these are basically where you use a knowledge graph and it serves kind of as the memory for these large language models, or I guess as an augmentation. And so this is not an officially supported Microsoft offerings. This is probably from Microsoft Research. Anyways, there's an open source repository here, and these are basically knowledge graph entities. So basically, you can take like a data set of news articles, and you could build a knowledge graph from that, all the concepts and words in that in those articles, and they're represented as a graph. How are they connected? How are they correlated with one another, and so forth. So you get this knowledge graph, and then you can use that as the basis for interacting with this large language model. And this talks a little bit about this recent preprint that they put out, and how you can explore community summaries and how these can answer global questions. So the community summaries are these knowledge graphs, and how this can help answer global questions, which address the entire data set rather than focusing on specific chunks of text. So, in a large language model, we're thinking of specific chunks of text. This is where you have an entire data set. It could be a news data set or something else. I don't know what news data set they're using. They have a repository here that has the contents of that. So, where naive RAG approaches based on vector search fall short. So they're improving upon these RAG approaches. For example, consider the question, what are the main themes in this data set? There's a reasonable starting point, but one where naive RAG will always give misleading answers. This is because it generates answers from chunks of text semantically similar to the question, not necessarily from the subset of input text needed to answer it. However, if a question addresses the entire dataset, all input text should be considered. Since naive RAG only considers the top k most similar chunks of input text, it fails. Even worse, it'll match the question against chunks of text that are superficially similar to that question, resulting in misleading answers. Community summaries help answer such global questions because the graph index of entity and relationship descriptions has already considered all input texts in its construction. Therefore, we can use a MapReduce approach, so that's a specific algorithmic approach, for question answering that retains all relevant context from the global data set. So they take this entire knowledge graph, they compress it down to this, I guess to a query or something like that. They kind of talk a little bit more about their evaluation and results here. And so, yeah, this is a interesting kind of approach. So yeah, thanks for, I guess it was Morgan who posted that in one of the channels. I can't remember what channel it was.
Yeah, I mean, I don't think necessarily like super novel, and like you said, I couldn't pin down exactly what open source license they're using.
MIT, I saw MIT.
But yeah, but that does seem, it does seem to be one of the kind of big themes in terms of large language model, like, I don't know, extensions or
yeah.
And of course, what I'm really thinking about is how what architectures help support us in particular for biomedical data sets, right? Just in particular, I think their examples are definitely more kind of text based, but again, like a lot of these, especially enterprise applications, is trying to utilize a bunch of structured or unstructured texts that the companies have. I think we would be more interested in that kind of, what about these biomedical data sets and how those are being used, but those, which is luckily becoming its own little subset too, or at least, we should cover that big, what's the, I forget now, was it EMC? It's the protein folding team from Meta.
Oh, okay. I'm not sure.
They've got a new model. Anyway, there's definitely lots of corporate interest in biomedical models too.
Yeah, I know that now Lucas Bastani is working on a project for OpenWorm. It's an OpenWorm studentship, and he's doing things with proteins and getting proteins, a certain list of proteins or a certain set of candidate proteins, and he wants to integrate that with C. elegans development. And so part of that, of course, is working with annotations, working with the kind of data that where you would say this protein is associated with this process. And there's a lot of annotation data, but the annotation data is a bit, it's both vague and not necessarily well connected to the problem, because you'll get like very well, you'll get things out of papers, like we've been going over papers that kind of mention these proteins and how they're associated with some pathway or some process, and you have to kind of, put all that together. And I think it'd be kind of an interesting approach is to take kind of a graph approach to it in some way, where a knowledge graph or maybe even a graph neural network approach um, to this problem. But this is not something he's doing. He's really interested in building just kind of an analysis pipeline. But it's not something, because we'll have access to these data, and we'll have access to some of these more focused problems. It's not a huge, genome-wide problem, or like a huge.
No, for sure. I mean, again, it'd be good to go back and see what some of these efforts that have some momentum, like I think it's Brain LLM. What's the Brad Joy project? Where he's definitely trying to make a tool based on like academic literature as well as any kind of neuroscience research output that is in accessible databases, to be able to say like things that maybe Lucas be interested in terms of like what proteins what would be interesting proteins to model or to look at their expression given C. elegans and some sort of manipulation, right? Like what he was definitely talking about in the his brain meeting, it's like his UCL talk was just like trying to create an LLM that is like a scientific not advisor, but kind of like suggester.
Yeah.
Yeah, like these would be Brad Joy.
Yeah, Brad Joy. Okay.
I mean, let me just double check. Yeah, I think there's like, and then Brain LLM. It's something, these.
Or I was trying to get the most cutesy name for their.
If I'm misremembering, I can totally find this in 1 second, Jess. But go ahead, keep talking, and I'll pull it up, because I know who was working on his. They did a hackathon, and
okay. Well, I'll just keep going on the papers and.
Yeah, please.
Yeah. So this is something that was put in the Google Summer of Code. This is, I think, by Jess, which is something from the Chan-Zuckerberg initiative. So, Mark Zuckerberg and his wife put a bunch of money into this initiative, which is biomedically oriented. So, people are doing all sorts of biomedical science or biological science. They have pots of money for them, and it's in a stress open source development. So this is essential open source software for science. This is where we have a number of different projects that they sponsor, and these are all open source projects. So these are all developed. They have kind of a goal behind them, and so this is actually 3D Slicer. So this is something Hussain was exploring. This is 3D Slicer in my language, internationalization and usability improvements. And this is, kind of talk to increase the accessibility of 3D Slicer, open source platform for biomedical research to clinicians and scientists in non-English speaking countries. And so this is, one example. Number of 3D Slicer projects, the number of projects, a hub for probabilistic analysis of single cell genomics. So this is to develop SCVI tools 2.0, an accessible and scalable environment for probabilistic modeling for single-cell genomics that enables the next generation of massive scale studies. And so, you get all these different types of toolboxes, different types of interfaces with existing toolboxes. This is a project, a solid foundation for statistics in Python with SciPy. So this is where the project will improve the SciPy library statistics functionality to better serve biomedical research in downstream projects. In addition, the outreach component will engage female students, inspiring them to participate in open source code development. So some of these projects have an outreach component too, which I think is, it helps to build the community. And so it's something that, this is actually something that is very similar to what NumFocus is funding. So NumFocus is a group where they fund, they give funding to open source projects to improve their projects. And so there's a kind of a connection to this as well. So there are a lot of things where people are either plugging into an existing platform, or they're building their own platform, or they're kind of building their community, or doing outreach. So a lot of interesting things going on there. Okay. Oh, Brad Love, not Joy. Yes, it was Brad Love.
Yeah. I totally. It's interesting how I misremembered that.
Well,
and it was Brain GPT, not.
Brain GPT.
I forget what I said. Brain LLM or something like.
Yeah.
Like anyway.
Yeah. Different emotions. Sorry.
Yeah, they and yeah, it was really interesting to see what what Chan-Zuckerberg was supporting in terms of I think they also try to make an evaluation of what are sustainable projects,
right.
And what it'd be interesting to know more about their evaluation process, and what if any metrics they use.
Yeah. Well, I mean, I've done some of this kind of work where we're evaluating projects, and it's really, you just have to think about, it's kind of like how we evaluate Google Summer of Code projects. It's like giving a proposal, how much can you actually do in the time allotted with the amount of money that you're requesting? Can you do the work? So, a lot of people request money for a maintainer or a student, and they'll try to rewrite a code base. That's not going to work. You have to focus your efforts on something very specific. And then, if you're asking for $5,000, that's maybe a studentship. That's what it funds. Or it might fund someone for a 2-month period. So you have to kind of think, okay, what can I do in 2 months? And that's pretty much how you would give money, how you would say, okay, this is a good tractable way to improve your project. Sometimes you want to do community building. You could say, I want to build out our community. We want to maybe, get that process started. You wouldn't hire a community manager, but you would say, I want to just kind of work on some of the, infrastructure for building a community. And that's basically what you would do. And it's just sometimes, projects fall in the rut of neglecting things. So they lose momentum by neglecting a lot of things. And so this kind of funding helps, because you can, target someone maybe who's been wanting to work on a project, but it hasn't had the incentive to do it. You can get them some funding and they can do something. This is something we've had with DevoWorm a lot, where we've kind of had to figure out how to move to the next step. And it's getting people to do things, through studentships or something else, through small funding opportunities. That's one way to do it. So it's quite enabling, but at the same time, it's hard to get those little projects kind of strung together to, Okay, so the second thing I wanted to talk about here is I think this was something Jess also shared. So this is a nice tool if you're thinking about your own open source project and you're building a repository for the first time, and you're like, okay, now what do we want to do about the license? So I do a project management course, and we spend a decent amount of time talking about open source licenses. Now, the thing about open source licenses, of course, is that it helps people kind of maintain, like, start off with good protections for their intellectual property. So if we think of open source, we think of it as being like a thing that you freely share with the world. But there are a lot of legal considerations to make. You don't want to just say, here's some software and use it any way you want, and that be that. Sometimes people want to sell parts of it. They want to make some sort of commercial distinction between the things that they might want to sell or benefit from financially in areas where they just kind of let people use it. You saw with the Microsoft projects where they had their repository, that they kind of made the distinction between Microsoft research as a whole and then this repository. Other times you want to have, like, you want to protect yourself in terms of liability. Like, if I'm putting this software into a repository and someone forks it, they can do certain things with it. They're not allowed to do certain things with it. And, there's, because, if you're giving someone this sort of fork, they can do what they want with it, and that can diverge from your plans for it. So you might have a roadmap. They might be doing something else, and those things would generally come into conflict. But a lot of times you want to make everything very explicit, legally, as well as like kind of just the sort of legalistic aspect of it. Putting it in writing, what you can and can't do. You don't want to micromanage people's forks or micromanage their contributions, but you also want to make sure people understand what the sort of limits to what they can do with it are. And so this sub sort of title says, an open source license protects contributors and users. And indeed, it protects people both from like internal conflict within the project and people who make forks. It protects them by sort of delimiting what the intellectual property is, how they can use it, but also how they can benefit from it. And so this is also important when you're using some other software. If you're using, like, a lot of times software projects will be based on other software, and there will be like this chain of forks where people are dependent on other software and people are dependent on your software. And having a good license is always important to making everything clear as to where the conflicts, to smoothing over conflicts. Because if you have a legal basis for it, you can just say, this is my decision, it's based on this thing that we've written down. We have this pretty well trod set of legal boilerplate that we can draw back, go back to if we have any ambiguity. So this says open source license protects contributors and users. Business and savvy developers won't touch a project without this protection. So if you're wanting people to sort of businesses to maybe make a fork or to invest in your project, or if you have developers who don't want to waste their time on something where they don't know what their benefits are for using it, or they don't know what they can do with it, what their legal liabilities are, then they won't bother with your project because you don't have a good license. Now, that being said, there are a number of very popular licenses you can choose from. So MIT, we talked about before, is one such license. We have other types of licenses from different open source organizations, such as Apache, BSD, and so forth. And so these are all foundations that offer licenses with different types of restrictions, different types of benefits, and you just have to go through and do your homework and say, what are the different licenses and what did they give you? So, it depends also on your project and how it's oriented. So some of these are very, like the MIT license, for example, is it says here, I want it simple and permissive. So what do I want for my license? I want it to be permissive. I want people to be able to do what they want, but I also want it to be very simple. This is something that the MIT license is very good for. So the MIT license is short and to the point. It lets people do almost anything they want with your project, like making and distributing closed source versions. So someone can fork your open source project to make a closed source version without any conflict. Someone's in your project saying, hey, you can't close off what you're doing. The license tells you what the conditions are. Babel, .NET, and Rails use the MIT license. Now, in this case, maybe I need to work in a community. I don't necessarily want the simplest license because I have a lot of concerns about what's going on in my community. We have evolving needs. So, and they may not agree on the same license. So use the license preferred by the community, which is where you allow the community to choose a license you're contributing to or depending on. Your project will fit right in. Now, you don't want to have multiple licenses for different people, but you do want your community to maybe have a say in which license you adopt. So this is where you can choose your license and the whole community can have a say. And that's sometimes a good solution because people, again, have different needs. And you want to know kind of what your community prefers before you pick a license. This one, I care about sharing improvements. The GNU GPL version 3 license also lets people do almost anything they want with your project, except distributing closed source versions. So in this case, you can make a fork closed source. With a GNU GPL version 3, you cannot. And so Ansible, Bash, and GIMP use the GNU GPL version 3. So you can see that there are two different licenses with two different sort of imperatives, especially with respect to forks. So yeah, what if none of these work for me? So, oftentimes what you want to do is you want to create a license early, put it prominently in your repository, make sure everyone knows what the license is. Sometimes you want to consult with your community, and you really want to think about in the future, where do we want this project to go? People start making forks. How do we want that managed? Do people start contributing in different ways? How do we want to make sure that there are no conflicts where people kind of claim ownership of things that aren't theirs, or vice versa? But what if none of these work for me? Then, sometimes your project isn't software. So there are licenses where you have non-software projects. And for those, sometimes you want to use something like Creative Commons. So if you have like a book or like some other content that isn't code, you don't want to use a code-based open source license for something that isn't code because they don't have the same protections. I mean, if I used the MIT license on an open source book, it's not going to protect certain aspects of that book. It's not the right type of boilerplate. So I need to pick a license, maybe like Creative Commons, where you can take, all sorts of different sort of contingencies of sharing, of access, of commercial activity, and put them together into a license that suits you. I want more choices. There are also other licenses. They kind of highlight some of the licenses here. There are licenses not only for open source software and open source content that isn't software, but for special cases like generative AI. There are a whole host of licenses for generative AI where it's not just software, but you're generating content, and it's a whole piece. So it's like you have the software that's generating stuff that isn't software, and you want to license, put a statement about the license for all of that. And then finally, I don't want to choose a license. And then they say, here's what happens if you don't. And they say no license when you make a creative work, which includes code. The work is under exclusive copyright by default. Unless you include a license that specifies otherwise, nobody else can copy, distribute, or modify your work without being at risk of takedowns, shakedowns, or litigation. So basically, you are open to a lot of potential problems. You can have litigation. You can have people forcing you to terminate your project. It's just a mess. And largely that's because, people sometimes are mean, but also they sometimes you can run afoul of, problems or other people's interests. And so you can't really, what they're trying to make the point here is that it's really hard to share your code when you don't have a license, and that open source licenses allow you to reuse your code while retaining copyright. if your goal is to completely opt out of copyright restrictions, try a public domain dedication instead. And that's the same sort of aspect to this, where if you want something to be in the public domain, you have to explicitly say it needs to be in the public domain. So, this is where this says for users. So sometimes if projects don't have a license, you can request to the maintainers that they have a license, or, something like that. Or, sometimes you don't want to use the software if it doesn't have a license because you don't want the hassle. Or you can sometimes negotiate a private license if you have specific needs. And so this is where you have to get your lawyer involved. So this is not preferable. But so yeah, that's a really interesting overview of licenses. Thank you, Jess, for that, for sharing that. Okay, so I guess Jess had to go. And so that's, I think, a good wrap up for the meeting, unless we have anything else we want to share. Okay. Well, thank you everyone for your updates, and have a good day, and talk to you next week.
Take care.
Take care.
Thank you. Bye.
Thank you. Bye.